For this lesson, we'll be looking at equations that have grouping symbols like the distributive property and like terms that you need to combine before solving the equation. So let's take a look at this first example. As you notice on the left-hand side, we have an example of the distributive property, 3 times x plus 4. So if we have 3 times x plus 4, we have to distribute the 3 to what else is inside the parentheses before we begin to solve it. So I distribute 3 to the x and the 3 to the 4. So I would have 3 times x, which is 3x, plus, because there's a plus inside the middle, my 3 times 4, which is 12, and that's still equal to 18. Now I can begin to solve that equation just like I would have solved the equations that we did in the previous lessons. I have to begin by trying to isolate the variable. So to isolate the variable, remember we get rid of the number that is on the same side of the equal sign as the variable. So in this case we're looking at the left-hand side of the equal sign, and we need to get rid of the number that's furthest from the variable. So that'd be the 12. So to get rid of plus 12, we have to do the opposite, which is minus 12. So I have to subtract 12 from both sides of my equation. 12 minus 12 cancel each other out because that gives me 0. We didn't do anything with the 3x, so we're left with it. We have the equal sign, and then on the other side, the right-hand side, 18 minus 12 is 6. Lastly, to solve this equation, we have to get rid of the 3. So right now the 3 is being multiplied by the x. So to get rid of the 3, we have to do the opposite of times 3, which is divide by 3. So again, I set up my division like a fraction, and I divide both sides by 3. These two 3's then cancel each other out, and I'd be left with x. And then on the right-hand side, 6 divided by 3 is equal to 2. So x is equal to 2. On this page, you have the exact same equation and the exact same work that we did just on the previous page. But this time, this stuff, or the steps, are justified. So looking at this, some of these justifications now are a bit different. They're not just a form of the property of equality like they have been with all the past equations that we've solved so far. So the first thing that we did was the distributive property. So we're labeling or justifying that step with the distributive property. There is not necessarily a reason why we did it other than, I guess, to simplify the equation. So we're just writing that we did the distributive property for that step. The next thing that we did was we subtracted 12 from each side. So that, like previously, is the subtraction property of equality to isolate the variable. The next thing we did was divide both sides by 3, which is, again, is similar to what we've done in past equations, so that justification is the division property of equality to isolate the variable. And then the x equals 2 is our solution. Let's take a look at a different kind of equation. If you're looking at this equation, you'll notice that there are not the distributive property expressions that you can simplify here. On the left-hand side, you should notice that we have two terms, 5x and 3x. Those are both like terms because they have the same variable with the same exponent. So before we can begin solving this equation, we need to solve it by combining like terms. So in this case, 5x plus 3x gives me 8x. So my equation simplifies to 8x equals 56. Okay, then I need to start solving for x. I need to isolate x. So I have my two sides of my equation. Right now I have 8 times x, so I need to get rid of the 8 by doing the opposite, which is division. So I have to divide, again, setting it up like a fraction, both sides by the number I want to get rid of, which is the 8. So then these two 8's cancel each other out, and I'm left with the x. I then have the equal sign, and then 56 divided by 8 gives me a solution of x is equal to 7. Again, we have now the same equation with the same steps that we did, but we have a little bit more in terms of justification. So the first thing we did was we combined like terms. So that is our justification. The first step we justify by saying that we combined our like terms. Then we divided both sides by 8, And just like previously, our justification is the division property of equality, and again we did it to isolate the variable. Then our solution is x equals 7. This is an equation that has both combining like terms and the distributive property within it. The first thing you want to start with is the distributive property, so you can get the terms that you can combine if you have any that are alike. So the distributive property is just this section here. So I want to distribute the 3 to the x and the 3 to the 2. The 10 isn't part of that, so it stays the same. And then I would have 3 times x, which gives me 3x, plus, because there's a plus sign in the middle of the parentheses, and then 3 times 2, which gives me 6. And then that's all equal to 31. So on my left-hand side, I have a couple of things going on there. I have constant terms, which are my 10 and my 6, because they're just numbers without a variable, and then I have 3x. So the next thing you should ask yourself is, to make this simpler, to have less steps involved in the actual solving process, what can I combine, if anything? So if we look at our terms, the first term we have in that equation is 10. I can put 10 together with 6 because they're both constant terms or just numbers without variables. So 10 plus 6 gives me 16. So my equation can be 16 plus 3x, because there's nothing I can put together with the 3x, is equal to 31. Now I don't have anything that's like terms on the left-hand side, so I can have my two sides of my equation, and I can begin to solve this. So again, I get rid of the term or the number that is furthest from the variable, but on the same side, the equal sign. So I want to get rid of the 16. So 16 is being added to 3x, so the opposite of plus 16 is subtracting 16. So I want to subtract 16 from both sides. 16 minus 16 is 0, so they cancel each other out, and I'm left with 3x. I have my equal sign still, and then on the right-hand side, 31 minus 16 leaves me with 15. Now I can look at getting rid of times 3. I need to do the opposite, so the opposite of multiplying by 3 is dividing by 3. So I want to divide both sides by 3. The two 3's here cancel each other out. I'm left with x being equal to 15 divided by 3, which is 5. On this last side, you'll see the same work that we just did, but the justification process becomes a little bit longer because we had more steps. So the first thing that we did was the distributive property. So my justification is the distributive property. The next thing we did was we simplified the expression or the equation by combining like terms. Then we subtracted 16 from both sides, so that gives me again the subtraction property of equality, and we did that one to isolate the variable. And then the last thing we did was we divided both sides by 3, so that would be the division property of equality, and again we did it so we could isolate the variable, and x equals 5 was our solution.